So here are degrees. Radians are a different way of labeling the degrees, labeling the angles. So a radian has to do sort of with the circumference. So the unit circle has a radius of 1. So does anybody remember how we find circumference? Okay, pi times diameter. So in this case, what is our circumference of the unit circle? It is 2 pi, because if our radius is 1, that means our diameter is 2, right? So this would be 2 pi. So if I go all the way around this circle, all the way around, I'm going to put 360 degrees here. If I go all the way around that circle, then my radian degree would be 2 pi. It's like the circumference of that circle. But let's say I don't want to go all the way around the circle. What if I want to just go all the way, like halfway around the circle over here to 180? How far would that be? That'd be pi, right? Because it's half of the whole circle. So your radian value for 180 degrees is pi. So what about 90 degrees? It's half of pi, right? And half of pi, we're going to write like this. Let me use black instead so we can differentiate these a little bit. So 90 degrees is pi over 2. That's half of pi. What's 45 degrees? It's going to be pi over 4 because it's half of pi, right? So half of pi over 2 would be pi over 4. Okay? So now what I start doing when I do these problems is, this is pi over 4, right? So this would be 2 pi over 4, which reduces 2 pi over 2. So if I go another eighth of the circle here, to the 135, what would that be? This is pi over 4, 2 pi over 4. No. So each piece is pi over 4, right? Like an eighth of the circle from here to here, 45 degrees. That is pi over 4. So this would be 2 pi over 4. So the next one would be 3 pi over 4. If I go another 45 degrees, that would be 4 pi over 4, but that would reduce to just pi, right? Then if I go another 45 degrees, that would be 5 pi over 4. If I went another 45 degrees, that would be 6 pi over 4. But 6 pi over 4, that will reduce to 3 pi over 2. So this is 3 pi over 2 right here. And so that was 5 pi over 4, 6 pi over 4, then this one is 7 pi over 4. And then the next one would be 8 pi over 4, but that would reduce to 2 pi. So each like eighth of the circle there is a pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Some of those reduce though, so we use their reduced values. So if I'm using radians, instead of saying 270 degrees, I say 3 pi over 2. We skipped a lot of them though. Now we need to think about the 30 degrees right here. I'm just going to go ahead and tell you. I could reason through it with you for a little while, but 30 degrees is pi over 6. So that means each little 30-degree segment of the of the unit circle is pi over 6, right? So if this is pi over 6, the 30 degrees is pi over 6. If I go another 30 degrees, that gets me to 60, right? That would be 2 pi over 6. But 2 pi over 6 reduces 2 pi over 3. So pi over 3. Right? And then if I go another 30 degrees, right here, to 90 degrees, that would be 3 pi over 6, which reduces to pi over 2. And then this would be 4 pi over 6, but 4 pi over 6 reduces to 2 pi over 3. So this is 2 pi over 3. If I go another 30 degrees, that is 5 pi over 6. Another 30 degrees would be 6 pi over 6, but that reduces to pi. Another 30 is going to be 7 pi over 6. Another 30 degrees would be 8 pi over 6, but 8 pi over 6 reduces to 4 pi over 3. Then, let's see, we're 8 pi, then we got 9 pi over 6, but that reduces to 3 pi over 2. That's 9. Here's 10 pi over 6, but that reduces to 5 pi over 3. I've got 7 pi, so that was 10 pi over 6. Then we've got, this last one is 11 pi over 6. Okay. So these are our angles on the unit circle. Everything we're going to do in this chapter, in the 5, 8, 9 chapter, the test, we're going to probably have our test next Wednesday. We've just got a couple more things to cover. Everything here, I'm going to let you use that sheet right there. So you don't have to have this memorized yet. Eventually, we're going to have it memorized for the next chapter. But right now, you don't have to have it memorized. So you can use that sheet on your paper. So if I tell you that the angle is 2 pi over 3, you can just say, oh yeah, that's the same as 120 degrees. And you can just think in degrees, which you're probably more accustomed to right now. There is one other thing I need to tell you. What about if my angle isn't something on here? What if my angle is something like 390 degrees? Okay, I would go all the way around once, right? And then that'd be 360, and then I'd go an extra 30, so it'd be right here, right? So if you have a value that doesn't show up here on this unit circle, you can subtract a full rotation. So if I subtract 360, then that gives me 30 degrees. So 390 is the same as 30 degrees, right? Same thing is true if I have, like, if I give you something awful, like 16 pi over 3. That's really bad, and it's not on here where I can look it up, right? How much is a full rotation if we're doing radians? It's 2 pi, right? So I could subtract 2 pi from this. I can't do it like it is because it is, right now, it is they do not have the same common denominator. So I would have to do, right over here, 16 pi over 3 minus 6 pi over 3. I'd have to multiply the top and bottom by 3 to get common denominator. You cannot see that in that gray. This black will show up. Right. So I could subtract those. I'd get 10 pi over 3. That's still not on here, right? So I could subtract another full rotation. So I could subtract 10 pi again, 6 pi over 3. So that would give me 4 pi over 3. 4 pi over 3 is on the unit circle. It is right here. So if you get a number that is too big, you can always get it to be something that is actually on this unit circle by adding or subtracting a full rotation. So you can subtract 360, or if they've given you radians, you can subtract 2 pi. Just with 2 pi, you got to use common denominators there. So you'll see that you have those. Also, unit circle always goes counterclockwise. If you have something that's negative, what I would suggest doing, like if they give you negative 150 degrees, that means it went this way instead. But you could just do this: add 360 to it, right? Because that's a full rotation. If you add 360 to it, then you're going to get 210 degrees, and there's one that's actually on the unit circle. So if you get something that's not on this unit circle, if you get an angle that you don't know where it's at, add 360 or subtract 360 until you get something that is there. And if it's radians, you can add 2 pi or subtract 2 pi until you get something that is on the unit circle. Okay, questions? All right, when you finish your quiz, you are going to go to Canvas, either on your phone or on a computer. And I have a video there for you to look at for this, and it's under assignments. Okay, and on this video, I will give you some polar graph paper to take your notes on, and then you have an assignment from the book. Once you watch it, it should not, this looks like a lot of problems, it should not take very long because you're just graphing points. Okay, it's something sort of new and weird, but it's usually pretty easy for kids. The only thing that might throw you a little bit is that radian stuff because we haven't practiced with it too much, but we'll practice more tomorrow. Don't get too worked up over that. For that.